Hi, welcome to the next lecture. In this lecture, we'll talk about what is an UART. Okay, before I'm starting, you have this document, you can download it, okay? I wrote here a couple of things, okay? And if I will add more, I will just upload it, okay, to this lecture, okay? So you can download it right here. Okay, so let's start. A UART is a universal asynchronous receiver transmitter, okay? It's a serial communication, very old one, okay? Now the protocol used for exchanging data between two devices, okay? It used only two wires, okay, TX and RX for each direction. And what it means actually is that for sending data from receiver to transmitter, actually to make them communicate with each other, we need only two wires, okay, one on each direction. And a UART is up to full duplex transmission. That means that you can be in simplex mode, which in transmission means that one side can send data to the other side, okay. Half duplex, it just two sides can speak, but only one at a time. And full duplex means that and this what UART supports, okay. Full duplex means that both sides can send data at the same time, okay. So if you think about a UART, okay, it looks like this, okay. I will touch it in this in a second, okay. And the format of the data is a frame, okay, with set of rules. We'll talk about this on the next lectures, okay. Now if we'll talk about if we'll think about a UART, okay, we have a shift register to transmit the data, and we have a shift register to receive the data. This is why it's a full duplex transmission. Okay, and let's just take a look. Okay, so this is how it's actually connected between two components, okay. If we are not thinking right now about the FPGA world, okay, we have two components. They can speak with each other in a UART protocol, okay, serial communication, okay. So right here I wrote again, it's a common used serial protocol, okay. Mostly it's being used in your PC, in your COM ports, in RS-232, modems, and more, okay. Yeah, we already said it's an asynchronous communication, but therefore, okay, the transmitter and the receiver do not share a common clock. Okay, when I'm saying that they don't have a common clock, okay, it doesn't mean that they don't have a frequency, okay. So the frequency between the both UARTs need to be set, okay, preset. Every bit has its own time, okay. So we need to know what is the bit time phase, okay. We will talk about this later on. Okay, now most of UART communication are just using RX and TX signals, okay. Sometimes we will see Rts and Cts built in UART chipset, and Cts mean clear to send, and Rts mean ready, okay, ready to send. And these signals are used for controlling, okay, the transmission itself. That just means that sometimes we want having some control, okay, over the UART protocol, okay. So think about two PCs, for example, connected chip to chip. So if you will have the RTS and CTS, you will one chip will tell the other, I am ready to send. Okay, so what it means actually, if you have a chip to chip direct UART link, okay, so if this UART want to tell this UART, okay, that it's ready to receive data, it will just send ready to send, and this one will get the clear to send, okay. So it means that this UART telling the other UART, hey, I'm ready to receive data, okay. So it's just controlling, not so commonly used, okay. Okay, in this course, of course, we will connect only the RX to the TX. This is the most common used communication for today. Right here we can see a regular connection between two computers. Okay. Now this is where we are coming to the physical layer. Okay, the physical layer will be on RS232, and this is just means that the UART communication being okay, the voltages being transmitted to a different voltages types. Okay, so the UART communication itself is just a protocol for the communication. Okay, how the frame set, how the frequencies and the baud rates and everything. It doesn't include what voltages we're going to use. Okay, how the data will change according to our board, okay, that we're developing on. Okay, so if you want up to 5 meters cable, for example, you can use RS232. Okay, so it's not so commonly used to connect chip to chip direct UART link. Okay, mostly it will go through RS232 line buffer or through COM ports. Okay, okay, these are the common baud rates. Okay, the standard baud rates are going to be between these numbers. Okay, so it's just you can see it's jumping. If you are familiar with these numbers, you can see it in your PC, in your COM ports. Okay, when you're setting up the baud rate sometimes. Okay, you can see this. If you use the Arduino, okay, for example, you can see these numbers. I think this one is the most common used in Arduino, and this one too. Okay. Okay, and this is it for this lecture. Okay, and I will see you on the next lecture, and this is it for now, and thank you.